air. Our Earth is a unique planet. The presence of the atmosphere has helped in making it so. The atmosphere is a huge blanket of air and is responsible for the survival of all living beings. Why is it called a blanket? That's because not only does the atmosphere provide us the air we breathe, but it also protects us from the harmful rays of the sun. Without it, the days would have been burning hot and the nights freezing cold. It is the atmosphere that moderates the temperature and makes it livable for us. The word atmosphere comes from the Greek term atmos, means vapor, and sphaira means sphere. It means the air between the Earth's surface and outer space. Composition of the atmosphere. The atmosphere consists of a mixture of gases which are present in varying proportions. Its major constituents are nitrogen 78% and oxygen 21%. The balance 1% includes carbon dioxide, helium, ozone, argon, and hydrogen. Impurities like dust, smoke, salts, carbon monoxide, and other chemicals are also present in the atmosphere. In its lower layer, the atmosphere contains water vapor too. Nitrogen is the largest component of atmosphere and is essential for the survival and growth of plants. Oxygen is the second most plentiful gas in the atmosphere. All living beings breathe in oxygen, while the green plants breathe out oxygen. Green plants use carbon dioxide present in the atmosphere to make their food. Thus, the plants help in maintaining a balance between oxygen and carbon dioxide in the atmosphere through the process of photosynthesis. If the plant cover is reduced, it will affect the balance between oxygen and carbon dioxide levels in the atmosphere. Structure of the atmosphere. The atmosphere extends up to 1600 km above the Earth's surface. The density of air varies at different places. It is highest near the sea level and becomes lower as we move further away from the surface. Based on the composition, temperature, and other properties, our atmosphere is divided into 5 layers. These are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Each layer is of varying thickness. Troposphere. This is the lowest yet the most important layer of the atmosphere. It extends to a height of about 8 km at the poles and 18 km at the equator. Being closest to the Earth, this is the densest layer of the atmosphere. All weather-related phenomena such as clouds, fog, rainfall, hail, storm, lightning, etc. take place in this layer. Here, the temperature of air decreases with increasing height at the rate of 1 degree Celsius for every 165 meters. This is known as normal lapse rate. The uppermost edge of this layer is called tropopause, and beyond this, the temperature stops decreasing. The troposphere absorbs maximum heat and protects us from excessive heating throughout the day and maintains a certain temperature level at night. Stratosphere. This extends to a height of 50 kilometers above the troposphere. The temperature is constant in the lower part of the stratosphere, but there is a gradual increase in the upper part. Stratosphere contains ozone, which absorbs the ultraviolet radiations of the sun. Being a cloud-free zone where no weather phenomena takes place, this layer is ideal for jet flying. The region of stratosphere with the highest concentration of ozone is called ozonosphere. It absorbs high energy solar ultraviolet radiation and protects organisms on Earth. Mesosphere. This third layer extends up to a height of 80 kilometers. Here, the temperature starts decreasing with height and reaches about minus 100 degrees Celsius at the height of 80 kilometers. Meteors burn up in this layer as they enter from space. Thermosphere. Lying above the mesosphere, this layer extends up to a height of more than 400 kilometers. Here, the temperature rises rapidly with increasing height. This layer contains ions, which are particles that reflect radio waves back to the Earth and enable wireless communications. It is called the ionosphere because of the presence of ions. Exosphere. This is the uppermost layer, which extends to a height of about 1600 kilometers and merges with the interplanetary space. The air here is very thin, containing gases like helium and hydrogen that float into space from here. Significance of the atmosphere. The atmosphere is of great significance for the Earth. Number one, it acts as a blanket and protects us from the harmful ultraviolet rays of the sun. Number two, the carbon dioxide helps the plants to produce their own food. Number three, it helps in keeping the earth warm by absorbing heat. Number four, the presence of oxygen and nitrogen is essential for the survival and growth of both animal and plant life. Number five, the water vapor in the atmosphere leads to precipitation and influences weather and climate. Weather and climate. Weather and climate are the two most often used terms in our life. Weather is the atmospheric condition in a small area over a short period of time, while the term climate refers to the average weather conditions of a large area over a long period of time spanning about 30 years. The weather of any area may change at short intervals. It might be windy at one time of the day or sunny and humid at another point of time. But climate of any place is of a permanent nature. Example, India experiences tropical type of climate, or Sri Lanka enjoys equatorial type of climate. The elements that influence the weather and climate are temperature, pressure, winds, humidity, precipitation, sunshine, and cloudiness. Temperature. Temperature refers to the degree of hotness or coldness of the air. The main source of this heat is the insolation or the amount of solar energy received by the earth. The amount of heat depends upon the latitudinal location of any place. It is higher in places near the equator and decreases polewards. The amount of insolation received differs from season to season and also between day and night. The temperature of any place also depends upon its height above sea level and its distance from the sea. Places located near the sea will experience moderate temperature, but those away from the sea will generally experience extreme temperatures. The temperature recordings are never solely dependent on any one factor. Various factors affect the climate of a place. Winds, ocean current, slope of land, and vegetation cover are the other factors that influence the temperature recording. A thermometer is used to measure the atmospheric temperature on a Fahrenheit or a Celsius scale. Air pressure. Atmospheric pressure can be defined as the pressure exerted by the weight of air on the Earth's surface. Air exerts pressure on all objects on the Earth. This is because air above us exerts pressure on the lower layers. However, we don't feel this pressure because air presses from all directions and our bodies too counter this pressure. Atmospheric pressure is measured by the instrument called barometer, and the unit by which it is measured is millibar. Air pressure, like temperature, is not uniform everywhere. It is influenced by the altitude of a place. It is highest at the sea level and decreases with increasing height. The temperature at any place also affects its pressure condition. Where temperature is high, air is hot and it expands and rises, creating a low pressure. But where temperatures are low, air pressure is high. Atmospheric pressure is also influenced by the rotation of the earth. The movement of air always takes place from high pressure areas to low pressure areas. Wind. Air in motion is called wind. Difference in atmospheric pressure helps the wind to blow. Wind direction is measured by an instrument known as the wind vane, and its speed is measured by the anemometer. There are broadly three types of winds. Number one, permanent winds. Number two, seasonal winds. Number three, local winds. Number one, permanent winds or planetary winds. These are winds which constantly blow in a particular direction throughout the year. Winds which blow from subtropical high pressure belts to equatorial low pressure belts are called trade winds. Winds originating from subtropical high pressure belts and blowing towards subpolar low pressure belt generally originate from the western direction and are called westerlies. Winds that blow from the polar high pressure belt to the subpolar low pressure belt are called polar winds. The winds blow in both northern and southern hemisphere. Number two, seasonal winds or periodic winds. These are winds which change their direction in different seasons during the year. They blow during a specific season. The monsoon winds in India blow during a particular season, June to September, and bring rain to the whole country. They change their direction with the change of seasons. Land and sea breeze are also seasonal winds. Number three, local winds. Blowing only during a particular period of the day or year, these winds have some specific characteristics and blow over a small area. Example, land and sea breeze. They are known by local names. Example, Lu, which are hot and dry local winds blowing in northern India in summer season. Other names of local winds are Fihan in Alps, Chinook in North America, Bara in Italy, Mistral in France, Ghibli in Libya, etc. Sea winds are also local winds which develop due to differential heating of land and sea in the coastal areas. Cyclones and anticyclones are variable winds. These do not blow in any definite direction. A cyclone is an area of low pressure surrounded by high pressure. Winds blow in a spiral manner at a great speed towards the low pressure center. They are accompanied by heavy rains and cause immense damage. An anticyclone is a high pressure area surrounded by low pressure. Gentle winds blow out in all directions from the center. They bring fine weather and clear skies. Cyclones are common in the tropical regions and are called by different names in different countries. Moisture or humidity. Water vapor is an important part of the atmosphere. Its presence in the air determines the moisture content and is called humidity. The humidity level varies from place to place and time to time depending upon the temperature conditions. When the presence of water vapor in the air is more, the humidity level is high. This is directly linked to temperature conditions. If the temperature is high, the rate of evaporation will be high, and so will be the humidity factor. In case of low temperature, the capacity of air to hold moisture will be less, and therefore the humidity level will be low. When the air is full of water vapor, we call it a humid day. The instrument used to measure humidity is called the hygrometer. Humidity is of two types, absolute and relative. The amount of actual water vapor in the air is absolute humidity. It is measured in grams per cubic meter. The amount of water vapor in air expressed as percentage is called relative humidity. Dew point. At a given temperature, the capacity of air to hold moisture is limited. When the air holds maximum water vapor, it is said to be saturated. The temperature at which air gets saturated is known as dew point. Condensation. As the temperature of saturated air falls, the water vapor in it condenses, forming droplets of water. Droplets joining together form bigger drops. Huge masses of water droplets are called clouds. Precipitation. When these droplets become too heavy to float in the air, they come down as precipitation. Precipitation is of different types. Precipitation which comes down to the earth in liquid form is called rain. The other forms are snow, sleet, and hail. Rainfall is the main source of groundwater, which is very important for the vegetation cover on the earth's surface. It is also an important source of fresh water. Very tiny drops of rainwater are called drizzle. The instrument used to measure rainfall is the rain gauge. Rainfall itself is of three types: convectional, relief or orographic, and cyclonic rainfall. Number 1, convectional rainfall. When a column of hot air expands, rises, and reaches the upper layer of the atmosphere, condensation of moisture takes place, leading to the formation of clouds. These clouds produce sudden and heavy rainfall. This is called convectional rainfall, and it is a daily feature in equatorial regions. Number 2, relief or orographic rainfall. The presence of a mountain or a hill in the path of moisture-laden winds forces the air mass to ascend along the slope, leading to cooling of rising air. This leads to condensation and causes rainfall. Such rainfall is called relief or orographic rainfall. The windward side of the mountain receives heavier rainfall compared to the leeward side. Number 3, cyclonic rainfall. When a warm air mass and a cold air mass meet, the warm air being lighter rises over the cold air mass, cools and condenses. This causes rainfall along the path and is called cyclonic rainfall. It is generally associated with cyclones. Rainfall is extremely important for the existence of life on Earth. It is not only a source of fresh water but also influences or determines the vegetation of any area. Pollution of the air. Any change in the composition of air is termed as air pollution. It results from the release of certain gaseous, solid, or liquid agents in the atmosphere. The obvious causes of air pollution are growing industrial activity, excessive burning of fossil fuels, rising numbers of automobiles, fires, and burning of solid wastes. The chief air pollutants are carbon dioxide, carbon monoxide, chlorofluorocarbons, suspended particulate matter, sulfur dioxide, nitrogen oxide, and lead. Air pollution leads to serious health problems, loss of biodiversity, and damage to historical monuments. It is a severe threat to the environment and must be tackled urgently.